am correct? Yes, 2AI. Here should be your serial number, of course. First portion of solution C plus litmus. The average titer value, which is VA, the one I used here is 8.80 cm cube. Then you go back, what is your CA? Yes, what's the concentration of the acid? The CA from the information given is 0.1. Therefore, this 0.1 means the amount in 1 dm cube. So first of all, you have to know the acid involved. The acid itself is HCl. Dissociate it, you have hydrogen. Welcome to Sir Majesty's World Science channel. So today we will be dealing with the waec past question on practical, the one that is just concluded. So we will take corrections and rub minds together, then try to contribute in modifying science. So our center number should be YouTube, and you know that. And then the candidate's number, simply do what? Subscribe. Please subscribe and share, and you have that center number, of course. So let's go to the next question. The first question. This video is meant to correct students and prepare them for future exams. We are going to take correction concerning this waec 2023 chemistry practical alternative A, and you can see that the time allowed is 2 hours. Okay, so we quickly move to the first page, and that's here. So in this first page, as you can clearly see, it says normal grammar, all your burette reading, all this. So we'll go straight to the information about A. A is 0.01 mole. They are telling us what A is. That is 0.100 mole per dm cube, while B is 0.03 mole per dm cube. You are advised always to use what is given to you in the question paper to calculate, and not what your teacher have told you before, or what any other person, YouTubers maybe like us, have told you in trying to guide you. Don't allow the information that you don't need to know, because the guides I give here are mainly for teachers. This one now are for students. Then for teachers also, for us to rub mind in case there is any place we can contribute to make waec better in a very polite way. Suggestion, we pray that our suggestion in the comment box will reach them, because we want the best for Africa, of course, but stick to the instructions, please. So they said it is the B is 0.030 mole per dm cube of triazo carbonate 4 salt. They say put A into the burette and titrate against. Yes, after that's the normal grammar. After everything, they say tabulate your result and calculate the average volume of A used. So what we're going to do first is to tabulate your result. Here is our ruler. Remember to make a neat table, and then to avoid cancelling your table. Cancellation of table might attract the loss of mark, and then use of pencil on your table may also attract the loss of mark equally. So we have this. Make a neat table for extra mark. Calculate the average volume of A used. So in calculation of the average volume of A used, what you just need to do there is remember that you should tell the marker. So average volume of A used should be equal to, I think the first, second, and third readings are all concordant, so I'm allowed to use any of them. So which should be, in this case, we have first plus second plus third. If you use 3, you divide by 3. Then to substitute the values, we have 8.7 plus 8.9 plus 8.8, all divided by 3, so that the total number should now be 8 times, yes, 8 times 3 is 24. So let's just use the calculator to be sure. 8.9 plus 8.7 plus 8.7, and what is here is becoming 9 unnecessarily. What's wrong with me? Plus 8.8, 26.4. 26.4 divided by 3 is 8.8, 26.4. So over here we have 26.4 divided by 3, which will give you 8.8. So maybe think black is more contrasting than this blue here. Rough, first, all in cm cube. Please endeavor not to cancel your table, and don't fill the table with pencil. Readings. So at least we stop there. We have settled 8.8 cm cube answer. Then we move to the next question. Is it on this page? Not at all. It's on the next page. So we come here. This is the next page, which says, from your results and the information provided, calculate the mole ratio of acid to the trioxocarbonate 4 in the reaction. Using this formula, what we're going to use here is actually CAVA all over CBVB equals NA over NB. We know everything here except the NA and NB, and that's the mole ratio. NA is mole ratio of acid, NB is mole ratio of base. So what is the CA? CA was given to be 0.1, while our VA, according to this, that's our endpoint, which is 8.8. And then our CB was given to us as 0.03. Stick to the real concentration given to you in this question paper. In any exam, follow the instruction in the question paper. Don't mind what you read in the textbook. Follow what they are giving you. They are checking your solving patterns. Then my VB is 25. Your school might use 20, but here is 25. Therefore, what happens is that it's going to be now 0.1 times 8.8 divided by 0.03 times 25, which 0.1 times 8.8 should be 0.88, all over 0.03 times 25 is 0.75, of course. So if you look at this ratio, what we are going to do in this case, if you divide this straight, you get 1.1 something. And hence, if you divide and get 1.1 something, it means that this is 1:1. The ratio of the acid to base is 1:1. This is where you have to be very careful. You try to change your endpoints in order to rhyme to 2:2. So no, don't do that. I have to, because this is about teaching you something. I'm telling you that you should don't change what? Don't change your end point just to make your acid base ratio 2:1. No, as far as this exam is concerned, they are marking your step why I did not get 2:1, though you already know that HCl reacting with sodium carbonate will give you 2:1. That's the ratio of acid to base. But why is it that I did not get this 2:1 here? Because the strength of the base was changed automatically. They purposely changed it. This 0.03 was not the actual strength of the base. This was not the actual strength of the base. So the actual strength of the base is 0.018 in that case, but use the strength given to you. Some teachers will go and manipulate so that their endpoint will rhyme to give them 2:1. If you change this endpoint, if you change this particular 8.8 to 15, you have your ratio 2:1. But unfortunately, it is not the ideal. Please learn this. That's why we are taking corrections. Therefore, we go back to our solving. That means that this is our final answer. This one on red should not be in your paper. I wrote it here because this is about learning. Okay, we go to the next calculation, which is still here. They said, given that B contains 5.0 gram per dm cube of dehydrated triazole salt, calculate the I concentration of anhydrous salt in B in gram per dm cube. Anhydrous means without water of crystallization, and therefore go back and remind yourself what is actually CB, meaning concentration of B was given to us as 0.03. This time around, they are asking us the mass concentration, that's the gram per dm cube. You use the formula which says that gram per dm cube is equal to actually mole per dm cube times molar mass. Mole per dm cube times molar mass. And therefore, the molar mass of, they gave it to us towards the end, molar mass of Na2CO3 is 106. Therefore, gram per dm cube here is equal to 0.03 times 106, which will give you what? Let's go to the calculator department. So we have 0.03 times 106 will give us 3.18 is the anhydrous according to them. 3.18 gram per dm cube. This is our final answer. So you underline double to show your final answer. We go to the next question, which is on the next page. Remember, you are not going to use this 5.0 to solve anything in this I. It might be used in the next question. Okay, so in the next page here we have, they say percentage of water of hydration in B. Percentage water of hydration is the same thing as percentage water of crystallization. Percentage water of hydration, first of all, is equal to mass of water all over to mass of hydrated sample times 100/1. So is equal to what? Mass of water all over mass of what? Hydrated sample or salt times 100/1. Therefore, the mass of water, how do we get it? Mass of water here is equal to, they give us 5.0 as the mass of hydrated, of course. 5.0, which is dehydrated, minus 3.18, if I'm correct. Let's check the last one we just did. Okay, 3.18, I'm correct. So, and if you do this, you have 3.18, not 3.8. 3.18, yes, of course. Okay, we have to, if you do this is 3.18. So 5 minus 3.18, 5 minus 3.18 is equal to 1.82. So that makes it equal to 1.82 gram is the mass of water. Therefore, the percentage water of hydration should be mass of water, which is, how do you get mass of water? Minus the anhydrous salt from the hydrated salt. That's what I did here. I minus the anhydrous, which is 3.18, from the hydrated, which is actually 5.0. So in this case, what you just need to do is now to continue with the formula we mentioned there, which is now the mass of water is 1.82 all over the mass of hydrated is 5 times 100 over 1. You'll get something around divide by 5. Divide by 5, of course. Then that's 36.4 times 100 over 1 is 36.4%. So the mass here is 36.4%. Some people will go and act as if they already know that the mass of water in sodium triiosocarbonyl decahydrate is 62. Please don't go claiming this thing. Solve according to the values given to you in the question paper. They change the strength of that hydrated salt, so that's why we are getting 36.4. They are marking your steps and not how really you are accurate in your analysis. You are learning. Most teachers will not even get it so accurate as you think. So now we have number of moles of hydrogen ions in the average titer value. First of all, they asked us the number of moles of hydrogen ion in the average titer value. The average titer value, which is VA, the one I used here is 8.80 cm cube. Then you go back, what is your CA? Yes, what's the concentration of the acid? The CA from the information given is 0.1. Therefore, this 0.1 means the amount in 1 dm cube. So first of all, you have to know the acid involved. The acid itself is HCl. Dissociate it, you have hydrogen plus chloride ion. So this means that 1 mole of HCl will automatically give us 1 mole H plus. So by so doing, what do we have here now? In that case, you have to go and find the actual strength present in this that's the actual concentration, the number of moles present in 8.80. Since 0.1 is the one contained, as this 8.80 is the average titer value, then it is already recorded that 0.1, this particular one, this 0.1 mole is in 1 dm cube. So what will you do? What you are going to do now is to ask yourself simple setting. I know you usually work with formula, but I want to make it clearer for you. Just say if 1000 cm cube, which is equal to 1 dm cube, was able to contain 0.1, what will 8.80 contain? Call it x, such that it's obvious now that 1000x is equal to 0.1 times 8.80, such that x alone is equal to 0.88 divided by 1000. So if you do this, what do we have? You move the 0 backwards again. That is going to be very small value. X will give us say the number of moles. Yes, we are correct. If the same molecule, we now think of multiplying by Avogadro, but since the same mole, we are just going with this correct formula. So we take it by this way. So 0.88 divided by 1000 is equal to 0. Of course, into 3 before 88 again. So give us 0.0088, and that is the number of moles of HCl. Then you go back, since 1 mole HCl will give us 1 mole H plus, it also implies that 0.0088 moles of HCl will also give us 0.0088 hydrogen ion. So this is going to be your final answer for this. So let's go to the next question.
Guys, Sama just took away my fear I had in chemistry and biology. You have to join the easy words. My name is Victor Modia, a student in Italy. Anywhere you are, you can join us. Join the easy word. Be a subscriber. Bye. Thank you.
The next one, we are done. This is about salt analysis. I think we are done with the titration calculations. I've advised you not to change your endpoint. Follow the instructions given to you. Then don't approximate their concentrations. Just for example, if they have told us that B is 0.05, don't make it 0.1. Don't write concentrations exactly the way it was given to you. So looking at this question, you know that candidate's number, of course, is this. We have to, isn't it funny? Yes, 07065166217. That's candidate's number. Who is the candidate? Sa Majesty. Please subscribe if you have not subscribed. Please, please, please subscribe to this channel. I cannot do without you. I thank most of you that have subscribed and they actually have been following me up. I really, really appreciate you guys. God will bless you. But let's do more academically. Every exam you come here, visit us and learn. We will teach you for free. And that's what I'm doing now. So let's focus on the SWOT analysis now. The SWOT analysis is all about telling us organic and inorganic, looking at the information there. So I have to get rid of this so that we can focus clearly. Okay, now C is an inorganic C is an organic compound, D is an inorganic compound. Carry out the following exercises on C and D. Record your observations and identify any gas or gases involved. State the conclusions you draw from the results of each test. Yes, put C into a test tube and then add about 5 cm³ of distilled water and shake well. Divide the resulting solution into 2 portions. Test the first portion with this. So what we are going to do here is, there are how many sub numbers here? Let's count it. You see, there are 1, 2, 3, 4, 5, and 6. So this is how you make your table. Make sure that in reporting, as we make our table usual, you have to have your test, inference, and then your observation. Test, observation, and inference in that order. So bringing our ruler, we need to make our table to start reporting. Okay, that's column for test, each column. Then observation should be wider. Then we have the inference column. So you are free now to make the line and then fill. You can write with capital letter or small letter, where here is your test. Let me remove the ruler. Test, observation, then inference. You write according to the question. The first instruction was they said C into test tube. So because of this numbering, I wouldn't know if there is any mark for that C, because it was just an instruction given to you. But all notwithstanding, I have to just teach you. But what you should do normally is just to write I, solution of C plus litmus. Yes, because they didn't number that, put C, that A. So, but for the sake of the fact that we are learning, you can say C plus 5 cm³ of what? Water. Then what is they have told you resulting solution, which means it will dissolve. It's not necessary, but because this video is just to teach, you can just say C is C, sample C dissolves to form a clear solution. But this is not actually necessary. Then you write C is soluble in water. Yes, just because I'm teaching. But regarding this question, this is not necessary. So after each test, you rule again. So we go to the major thing. You number it. That is 2AI, if I'm correct. Yes, 2AI. Here should be your serial number, of course. 2AI, you just write solution C. Okay, they say divide into 2 portions, which means you're going to write first portion of solution C. Yes, first portion of solution C plus litmus. What is your observation? No action on litmus, because C is actually glucose and is neutral. No action on litmus paper, or you can say there is no effect on litmus paper. You can say no action, or you say no effect on litmus. Though they did not say, okay, they say paper there, so no effect on litmus paper. Meaning, don't waste your time writing. It did not change red litmus. It did not change blue litmus. When you say no effect, it means it did not affect any of them. So what's your inference? You say solution C is neutral. Solution C is neutral, which means it's neither acidic nor basic. This is where your report is supposed to start from, because that is the one that will have mark. Okay, then the next one says to the second portion, that's AI, either this one is I, sorry, not I. This second one now is the I think the second one you are instructed to, let's remove the ruler. You are instructed to now, to the second portion, add 1 cm cube of Fehling solutions A and B and heat. Okay, so you now write 1 cm cube of solution. Okay, no. Okay, just second portion of so second portion of solution C plus 1 cm, specify as it is in the question. 1 cm cube Fehling's solutions is like, we'll turn to next page to complete this. Fehling solutions A and B. So let me turn to the next page. Yes, you still need to make the same table here. Okay. For tests. For observation. And for inference. Okay. Maybe I'll repeat that one. 2AI, second portion of solution C plus 1 cm cube of Fehling's solutions A and B plus heat. Your observation, remember, if you are continuing, is also wise. You write test here again. Is no problem. Observation and then inference. Okay, now in this situation, what will you observe on adding? No visible reaction on adding Fehling solution A and B. On warming, turns brick red. Or you can go straight forward and write orange red precipitate formed on warming, but the writing should be no visible what? reaction on adding Felling's solutions A and B, but a brick red precipitate was formed on heating. So what's your inference? Presence of reducing sugar, or reducing sugar present. Presence of reducing sugar. So that's it for that aspect. Okay, we bring our ruler. After each step, you rule off to demarcate you have finished with that particular question. I think the next one is to go to the 2bi. We go back to that question again to enable us see what 2bi said. 2b says divide D into two portions. Put the first portion into a dry boiling tube and heat strongly, then allow to cool. So what we are going to do here is just, since they use their grammar and answer their question, they say portion, so you have to say first portion. They say put the first portion of D, simple, plus heat plus cool. So turning to next page, you say first portion of D plus heat plus cool. You say turns yellow on heating but white on cooling. Zinc oxide confirmed. Is a feature that we used to know zinc oxide. So this is done, so we rule off again and go to the next. The other one say dissolve, if I can remember, dissolve in HCl and then heat, then filter if possible. Okay. To the first, they said to add 5 cm cube of dilute HCl to the second portion and heat, allow it to cool. Simple, dissolving D in 5 cm cube of HCl, dilute HCl. So it will dissolve, but there won't be any effervescence. This is where most students or the school that have wrong sample will get it wrong. So over here you are going, though they don't require these things to self, you just say D because it wasn't numbered. D plus 5 cm cube dilute HCl aqueous plus heat. They say filter if possible. Then you just say D dissolves to form a clear solution. Just because I'm teaching, D is soluble in HCl. Simple, but you are not necessarily, because this was not numbered. They say divide this into 2. The resulting solution, we were asked to divide it into 2. That means we are going to have the first portion. Let's go back. Divide the resulting solution into 2 to the first portion from 2bi. So you are going to write first portion from 2bii plus. Do you see how to report this now? So you don't need to repeat add. So first portion from 2bii. First portion from 2bii. First portion from 2bii plus sodium hydroxide in drops, then excess. Okay, you have to repeat aqueous here, in drops plus excess. This is they are testing for zinc, of course. You now write white gelatinous precipitate formed, which dissolves in excess of sodium hydroxide. Inference, since it's gelatinous, it's going to be aluminum or zinc, likely or present. So the next thing, it means you have to extend our table, because they say to the second portion you do the same thing, but this time around with aqueous ammonia, no more zinc. No more sodium hydroxide. So there are 3 ions that will form white precipitate with aqueous ammonia and dissolve in excess of it, which are aluminum, lead, and zinc. But why won't I put aluminum? Because it is gelatinous. Aluminum precipitate is gelatinous, zinc is gelatinous, but lead is powdery. Since the observation will give you powdery, you need to write aluminum or zinc. But most students, because of expo, your teacher have told you what you're supposed not to tell you, just write zinc present. So you see, it is supposed to just say aluminum or zinc present. Then the next one is a second portion from 2BII plus aqueous ammonia, dilute of course, in drops plus excess. You report the same thing. It's the same observation. White gelatinous precipitate formed in drops, which is soluble in excess, which dissolves in excess of the ammonia. So inference is zinc 2 confirmed. So we are done with the salt analysis. Hopefully, let's take a break and see this majestic periodic table. Electronic configuration itself is all written starting from hydrogen down to the organesium, that's one bearing atomic number of 118, that's up to 118. Then coming to the classification of the elements, this is just purely majestic. It indicated many groups and classes of elements that you never know they exist, and explained most trends. So it is purely a summarized chemistry textbook in form of a table. You see that classification you see there, you see the alkali earth metal, the alkali metals, the halogens, the chalcogens, indicating the common names of each group. Apart from the one that is commonly known like the halogens, you have the all formers, the chalcogens, the nitrogen family. This table has come to answer your questions as a chemistry teacher, especially if you are in the class teaching. Your job is just to point at that table, and the information you want will be there for you. Then this table do not only just contain the configuration, it shows the order, the half bar order, how the electrons fill the orbitals. Why do we write 1s first? Then after 1s we go to 2s, 2p. You see the arrow down indicating, and then it showed the number of shells present and the maximum electron each electron shell can hold. Their common name, the K shell, the L, M, N, and also showed the formula for the maximum electron each shell can hold. So I cannot mention them all. Place order for your own copy of this majestic periodic table. You will not regret it. I've come to help you learn chemistry. I've come to help you teach your students very well. Present this can hang it everywhere. Remember, the periodic table, the Mendeleev table, is one of the most popular table, and that's the table that represents science, even though it's chemistry. But anywhere you see that table hanging, automatically you know that this particular institution or this organization is scientific. Much love from me to you. Remain majestic. Bye for now. So we come here to the next question, which is random question. They say state what will be observed if few drops of sodium hydroxide solution is added to 2 cm cube of solution of each of the following salts: lead 2 trioxonitrate 5. This is just test for lead. Sometimes students might not know what to do. If you are faced with this type of question, just know there are 2 ions here, which are lead 2 ion and trioxonitrate 5 ion. We don't use sodium hydroxide to test for trioxonitrate 5 ion. Rather, we use sodium hydroxide to test for lead. So they are just asking you the test for lead. So what you should write here, they say what will be observed. You say there will be what? There will be white, chalky. If you don't want to use chalky, you can say there will be white chalky precipitate. Okay. The white chalky or white powdery precipitate, which dissolves in excess of NaOH. Simple. They did not ask you inference again because they have brought the anions. So students, when you teach them how to test for lead 2 ion, when they see this lead 2095, they now think, is there another different way? No. In salt analysis, most times we are detecting the presence of cations and anions. So if they give you any salt sample, you separate it into anions and cations and then detect them. So the same thing is applicable here. This is actually ion 3. This is not ion 2. This is ion 3. Ion 3 tetraoxosulfate 6. If you add sodium hydroxide to it in drops and in excess, there will automatically be reddish brown precipitate. Reddish brown precipitate is formed in drops, which is insoluble. This time around, insoluble. Or you say, if you don't want to say which is insoluble, you say which persists or remained in excess of NaOH aqueous. So we move over. Describe briefly how the melting point of benzoic acid could be determined in the laboratory. This is applicable to determination of the melting point of solids. First of all, you need to heat, most time a capillary tube. You heat it a gentle heat using thermometer. So here you must mention heat the solid of benzoic acid in a capillary tube, then with thermometer fixed. Then after that, when the benzoic acid turns liquid, you take the reading of the thermometer, and the reading in the thermometer automatically represents the melting point of that benzoic acid. This is quite simple. There is no special thing. It's just the same mechanism to determine the melting point of any solid. Okay, so then the little comments I have concerning this actually is that this particular salt analysis, the analysis of the zinc oxide, where students were asked to add HCl. See the point I'm trying to raise here. This particular place, to add 5 cm cube of HCl here in this particular point now is not The problem there is that the examiner, they just say dilute. They don't know the strength of the acid. If they say dilute acid, of course 0.1 is dilute acid. You can take 0.1 as dilute acid. You can take 0.1 dilute, 0.2, 0.5, 0.5 is also dilute acid. So though they said filter if and if necessary, fine. But what if the acid, the HCl provided, was too strong that it will dissolve the whole carbonate, there won't be any filtration? If the acid strength and the carbon, not the carbonate, and the oxide, the zinc oxide provided, because D is probably zinc oxide and C is glucose powder. So what I'm trying to say here to my co-chemistry teachers, for those that go for audition, I don't have so much problem with this, but there is a slight problem, which is the strength of this HCl, because dilute is not specific. Unless they will specify what they mean by dilute, there is no strength that you actually comfortably call dilute. So a teacher can provide 0.3 mole, 0.2, 0.5 mole, even 1 mole per dm cube HCl is still considered dilute. Yes, of course. So what if the strength of the acid is too much and dissolves the whole zinc oxide? There won't be any need to filter. Then what will such child do? What will be the implication? If you come down here now at this stage, the problem is that when you be adding, let's go to the next page so that you understand what I'm saying. When you be adding this sodium hydroxide in drops at this particular stage, now you are adding sodium hydroxide. What if there is excess acid at this point? If there is excess acid, the acid will consume this sodium hydroxide such that the student might not notice any precipitate. Why? Because there is excess acid which will consume the sodium hydroxide first, because the sodium hydroxide will be used up to neutralize the unreacted HCl, and the student will be forced to report no visible reaction. So the message I'm passing to waec from this is that such questions that are not straightforward, that if a child, because for me, I train children that do this thing on their own. I love science, I love real research. So I also love it when the questions are real, such that it will not be interpreted in one or two. So you don't just say dilute. I know why they said heat is that they are assuming that the acid is too weak. There is no strength called, they tell us to provide as bench, because this is bench HCl we use for research, not the standard HCl they told us to prepare for titration, but the normal ones in the reagent bottle. So I am of the opinion that waec should not repeat this, as far as because any child that really want to do the practical and he is faced with this type of thing, you see the child reporting no visible reaction on adding sodium hydroxide. Reason: because there was an excess acid that consumed the base he was adding, or she will be adding. Even when the same thing will happen with aqueous ammonia. I don't know if you are practically inclined, you understand what I'm saying. So the summary of all I'm saying here is that in that number 2, let me go and pick it well. In this number 2b, that number 2bii, it shouldn't be. I know it's possible, but for them to put it number 2bii, let me comment it here. Yes, for number 2bii, where students were asked to add 5 cm cube of HCl to zinc oxide, of course that was D. I'm saying that the strength of this acid was not specific. The strength was not specific. So what if a child happened to have HCl that is up to 0.5 mole, or possibly that is even up to 1.0 mole per dm cube, and add it to that half spatula of zinc oxide, and the whole thing dissolves? Most times the teacher might, the zinc oxide might be half spatula, and the child might not divide it perfectly well during heating, so it might have less than half spatula, And when the whole zinc oxide dissolves, leaving behind excess HCl, which will consume any base like sodium hydroxide to form salt and water first. After the whole acid has been consumed, that's only when the sodium hydroxide will start reacting with the zinc to form any precipitate at all. So if the acid happen to be stronger than normal, so if this question is coming, I'm suggesting for waec to specify the strength, to tell the teacher to provide the dilute acid of so strength and do the measurement by themselves. When they are saying 5 cm, they have estimated the number of moles that will be there to avoid a child having excess acid, which will consume the base when he's adding in drops, and the person will be forced to report no visible reaction. So this is the end of this video. I so much appreciate you. Thank you for watching. Please subscribe and share. Then I will also like your contribution in the point I'm raising here. If you are with me or if you are against me, let me know, correct me. But this is, we are trying to make a perfect body, exam body. Yes, because when I handle the Cambridge students, the questions are more practical and not, there are questions that when you go and do it, you won't have any challenge. Not just whatever you remember you ask. Check other predicaments that the child might face, which will, this time around, they reported zinc. Some persons reported zinc out of assumption because they have said sodium hydroxide and he heated a solid, it was yellow. Then the person will know automatically, suspecting something like zinc oxide. Do you understand that now? So the child might, by forging, say, even when there is no visible reaction, say, I already know that sodium hydroxide is used to test for zinc, aluminum, and lead, then ammonia is used to confirm it, and write it that way. But that doesn't really make the child a pure analyst. So thank you once again. Remain majestic. Bye for now.
Wait a minute, have you heard about Sir Majesty Easy Word? Well, I'm a subscriber to at Sir Majesty Easy Word on YouTube, and I'm a student at University of Camerino, Italy. Sir Majesty made science so easy for me, and it took away the fear I had on chemistry and biology. Distance is not the barrier. Guys, you have to join the Easy Word today at www.easywordscience.com and on YouTube at Sir Majesty Easy Word. Bye. Thank me later.